This question centres around trig functions and inverse trig functions. It's probably a good exam 1 standard question, and it would be a great one for us to have a go at. Alright, part A. We've got to show that sine of pi on 12 is root 6 minus root 2 all over 4. Alright, well, I smell a compound angle formula, don't you guys? So hopefully you would know that pi on 12 is 4 pi on 12 minus 3 pi on 12, which just gets you pi on 3 minus pi on 4. Okay, so now do you know how to do that? Hopefully it just rattles off your tongue as easy as pi. So it would be sine pi on 3 cos pi on 4 minus cos pi on 3 sine pi on 4. Without having to look up the formula sheet, it should be in your brain, burned into your BIOS, guys. Have I got the message loud and clear? Don't look up formula sheets, it's a waste of time. Get it into your brain, only use them if you have a mental blank. So, okay, that becomes root 3 on 2 sine pi on 3. Cos pi on 4 is 1 over root 2. Cos pi on 3 is a half, and sine of pi on 4 is 1 on root 2. So, combining that, we get root 3 minus 1 all over 2 root 2. Now, all we've got to do now is multiply top and bottom by root 2, I think, and we'll be laughing, guys. Yes, very nice. Okay, that was nice and simple, but it wouldn't be nice and simple if you couldn't see how to start. Okay, now what have we got to do in part B? Well, if y equals 2 arc sine minus 2x minus 2, state the implied domain and range of y. Oh, that's not so bad. These are easy if you know how to do them, guys. Alright, so y is 2 arc sine minus 2x minus 2. Therefore, putting it in that form, y over 2 is arc sine minus 2x minus 2. Now, therefore, the x bit, the minus 2x minus 2, has to go between minus 1 and 1 inclusive. Let's solve that now for x, guys. That's all you do. That's all you do. So I'm adding 2 to both sides there, and I'm getting minus 2x, therefore goes between plus 1 and plus 3 inclusive. Now I'm going to divide by 2, and I get that. Would you agree? Now the last step, be very careful. You have to reverse those little beasties here. I call them the crocodile mouth. You have to reverse the direction of the crocodile mouth when you're multiplying both sides by minus 1, and you get that. Alright? Yes, did you see what I did? I reversed those crocodile mouths, didn't I? So therefore, putting it round the way that we're more used to, you would say that x is greater than or equal to minus 3 on 2 and less than or equal to minus a half. Okay, with the less than at the left-hand end and the greater than bit at the right-hand end, as you'd see on a number line. Okay, that's that bit done. Very easy, isn't it? Now, what about the y now? So y over 2, harking back to here, y over 2 would go for an inverse sine function, or arc sine or r sine function would go between minus pi on 2 and plus pi on 2 inclusive. Solving that for y, we would get that. Yes, put a box around both of them, and we're laughing again. Yes, excellent. Well, we're clocking up some marks here. Let's see what they try to do to us in part C. It looks horrendous, doesn't it? If arc sine minus 2x minus 2 plus this beast, which relates to up here, if y equals all of that, find the value of k such that y is always going to be negative. Now, what I'm saying here is, if this thing here is what we're saying, is if this thing here by itself, without the add-on bit up here, is normally from minus pi to plus pi inclusive, therefore, if this combined expression here, making up this y function in part C, is always going to be negative, okay, that means that this contribution here must always be less than minus pi. In other words, it pushes it down by more than pi, right? By more than pi. So it's always under the x-axis. That's what I'm saying there. K sine pi on 12 has to be less than negative pi, all right? Now, putting the number that we found in here for sine of pi on 12 was root 6 minus root 2 all over 4, so k times that is less than minus pi. Solve it for k, and you get that. Yeah? Are you okay with that? Great. That's fine, and that's the answer to it, okay? It sparks worse than its bite, isn't it? Which is usually the case with specialist maths. If you just have a look through it and keep your head and don't get stressed, the answer is always there. It's never very far away. In fact, that's one of my mottos. The answer is never very far away. All right. Hope you got something out of that, and we'll see you soon.